All right, welcome back. We are Game 2014 in the fall 2021 semester, and it is week 7, part 1 of our broadcast. And this week we have a couple things happening that we need to talk about. One thing is this week is exam week, so we have our midterm practical test that is going on. I released the test details yesterday, and the test is due actually on Sunday is when it's due. So it said Saturday somehow, but it's actually due Sunday. So that is the thing to know about this one. We're also talking about touches, input, presses, gestures, and the Singleton design pattern, which is something we're talking about this semester and in this today, actually. All right, so that's what's happening here. A couple additional things. So again, assignment 1, part 2 is due Sunday. Your midterm test is also due, it should say Sunday, not Saturday. That's something that's happening. We're going to be talking about the Singleton design pattern, and we're going to transform. Last week we did this. We actually transformed the factory into a Singleton and the BulletManager into a Singleton as well. I'm going to go over this a little bit more detailed this time around just to make sure you guys are good with it. So that's what we're going to do today. We're going to start off with the Singleton. And then after that, I'm going to go through the midterm details in a separate video. So that way, there should be no question as to what I'm looking for in the midterm. Usually that in the first section that took us about 2 hours, I think we'll probably be a little quicker in the second section as normal. So Singletons, what are they? So it says right here, it says it lets you ensure that the class is only one instance while providing global access to this instance. All right, so that's what it does. It's like a global. We're going to talk about it. And we've seen Singletons before. It's a creational design pattern. It's not like we've never seen them. We've been using them since our SDL days in C++. And so we're just extending that, and we're continuing to use them here in Unity and in with C#. So what is a Singleton? It's a creational design pattern. Again, it allows you to have one instance while providing a global access point. So that's what we've seen before. We use them a lot of times for very important classes and objects we want to have access to, where we don't want that class or object to be duplicated in any way. In some sense, it's a safety measure, so that way there's only one, let's say, for example, texture manager or collision manager or bullet manager or whatever kind of manager. Usually it's assigned to managers or something that's important. One thing we want to talk about today is we don't want to overdo the Singleton design pattern. We don't want to use too many of them or use them indiscriminately, because then it becomes a mess. It's like we're using a bunch of globals. All right, so we'll talk about that in a bit. So again, here's the problem. Really, Singleton solves two problems, not just one. The first problem, and this is where it violates the single responsibility principle. We kind of talked about this, solid design patterns and what they mean. So number one, we want to make sure that a class, and usually it's an important class, has one instance. Okay, that's the first problem that it solves. And so this way we control access to some kind of shared resource. An example of this would be some kind of database or file or something that we don't want multiple instances of, because it could cause a clash in our code. So that's what we want. So that's the first problem it solves. And the second problem it solves is some kind of global access point, right, to that instance. So that's where it breaks the single responsibility principle. Remember, single responsibility principle states that a class or method should just do one thing and only one thing. If it does more than one thing, why? It shouldn't be doing that, because then what we're doing is it's harder to maintain, and it's and extend and so on, and you don't need to do it that way. So let's talk about the two problems that it solves. So again, from a solution perspective, the way we would solve this problem is what we're going to do is we're going to make our default constructor private. And that's what we've seen before in the past. We make our our default. So when I say default constructor for you, in your mind, it should mean um, the empty constructor, the constructor that does not take any parameters, not a parameterized constructor. So the default constructor is private to prevent, and actually all constructors really should be private at this point, to prevent other objects from using the new operator. And the new operator in C# or even in C++ allocates memory and instantiates a new object of that type, whatever that is. We're going to create a static creation method. A lot of times this method is called instance or get instance. Those are two very common ways of doing it. And this creational method is going to call the private constructor. It kind of acts as a constructor, but it creates an instance of this class only when the object is called for the first time. When I call the class, the instance creational method for the first time. And the other thing it does is this static method is called once, and it kind of uses something called lazy initialization, which we're going to talk about in a bit, to only create an instance when I create a new object. Okay. So again, real world analogy, it's like the government. There should only be one government of a country. Typically, you can't have more than one. So it's like a kind of a global point of access for, that identifies a global or a group of people that are in charge, right? And the way the structure looks like for us is, and again, this is your UML code. You have a Singleton class, and notice that we have an underline here. Does anyone know here, that's in our course right now, what the underline means in this context? What does the underline mean? Any one of you can answer. I'm also looking at the people online on YouTube. So any one of you guys or girls can answer and let me know. Any person. So what does the underline mean in the UML diagram is what I'm asking. You guys are a lively bunch this afternoon. I can see that I'm getting all kinds of answers. Not. So what is it? Well, the underline, so this part right here means that the object is a static. So yeah, so underline means static. Whenever we see an underline in the UML diagram, that's what it means. And the other thing that we also have to think about when it comes to UML is this symbol here. The minus sign means it is private, and the plus sign means it is public. So that's what those things mean. This part here is the class name. This part here usually is the properties, and this part here is usually the operations or methods. Those are the three parts of the UML diagram, the class diagram. So that's why we brought it up. So what this is basically saying is a singleton requires an instance property that returns a singleton object of the same class as the singleton. It's a private instance, and its underline means it's a private static instance. We also have, and I'm not sure why they put it here, because really this should be in here, right? Because it's an operation. The method or the constructor should be a private constructor. The default constructor should be here in the operations. It's a private constructor, and what happens is the get instance creational pattern calls the private constructor here through the new keyword and only returns, as an example, a new instance if an instance doesn't already exist. Okay, that's how it works. Okay, so the instance, which is here, it got created, and it only returns an instance if one doesn't exist, and we check for that existence right here. There is kind of like a sentinel, that basically checks to see if the instance is not null. If it's null, we create a new one. If it's not null, we just return the same instance back to the calling client. That's how it works. Okay, so really it's pretty simple. We've seen this kind of structure before, and we've seen it in C++ when we were doing it then. So that's the structure we just talked about. So when do you use it? Again, we use for the first problem to solve, we use a singleton when we should have one instance, usually for a manager type class, something that's important. And the second reason is when we want stricter control over some global variables. Sometimes also, some people asked earlier in this in the first section, how about if I don't want to use a singleton? Is another way to do it, and the other way to do it would be to create it inside of a namespace context. Sometimes we use namespaces, and namespaces are good enough for global access. So those are the two things. Again, it doesn't really satisfy all the requirements of a singleton, but it can get us through. We use the get instance method, and I want you to think about the get instance method as a doorway to the object itself. So again, let's just do this. Sorry, another diagram here. But let's suppose I have the class object here. Here's your class, and I want to make an instance. The only way I can create an instance, because our constructor function is private, is to go through this public method right here. This public method is the doorway to the rest of our class. It allows us to access methods and everything through. So this is the strict control we're talking about. So the only way that I can get access to this is through this creational method usually called get instance or instance. Those are the two things. I've called it instance in our example, but this get instance method allows us to access other members or other things inside the class, and it also instantiates an object of type whatever this class is called, right? So that's what it does. How do we implement it? We talked about this. We use a private static field to store an instance and so on, things that we talked about earlier. Let's give you some examples. So the classic implementation is something we've seen before. And this, you can see this is right out of Visual Studio and C++. We had a class, let's say, called Singleton, and it doesn't matter what the class is called. It could be Texture Manager. And then we have a public static instance creational method. That's what this is. That returns a pointer to the Singleton class. We check to see if an instance, which we've defined here in the private area of our header file, if this private static instance is not null, and if it's not null, then we just return with the instance that's already there, a reference to the same pointer. Or if it is null, we create a new instance. We allocate memory with the new keyword. That new keyword puts aside memory on the heap for us, and we're able to use that that instance. A couple of other things we should take care of is the copy constructor and the assignment operator, as well as the destructor. That's kind of like the big three, if you will, that we should do for every single class we make in C++. One thing to note is this classic implementation, the way it is right here, is not thread safe, which means it's not something that works well with multi-threading environments. If I want a different thread or to kind of work with one instance compared to the other, it doesn't work well. Actually, what it does is it creates multiple instances of the singleton, which kind of goes outside of what we want for this thing to work like, and it can actually crash your code. It can do a bunch of really weird things in this implementation. So instead of this, when it comes to multi-threading, if I want to use multiple threads, then or in a concurrent, for concurrency purposes, right? Want things to run at the same time. I want parallel programming in some ways. Then I want to use something called magic statics in C++. Magic statics have been around since C++ 11. So they've been around for a while. They are thread safe, and the difference is the way that the instance gets implemented. So again, we have our instance creational method, and this time, instead of having a private static instance that returns a pointer to the singleton, we use the magic static right here. So in other words, we don't have an if statement. We don't check to see if it exists. Because it's already static, the first time it gets created, then we have an instance. We just return that back in. If not, then a new one is created if one doesn't exist. If this is null pointer, magic statics allocate memory when we need them. And notice that there isn't a pointer that we need, but rather a reference to the instance creational method is what we return, which is pretty cool. And again, we see that the syntax for the copy constructor and the Simon operator are also slightly different. And we've removed the private static pointer instance, to the class itself. So that's kind of something that's different. This is also using Magic Statics use something called lazy initialization. Again, exactly what we're looking for, where when we instantiate an object of type Singleton, it's stored here, but only when it accesses the instance creational method from outside the class, just like what we want. This is also sometimes called the Myers Singleton, using Magic Statics, and it was originally created by Scott Myers. Take a look at this. I've included a kind of a blog entry here back from 2017 about the perils of double-checked locking, when we use something called concurrency or multi-threading. All right, so that is your Magic Static implementation. And in C#, people have asked earlier today, what about in C#? Do we have Magic Statics? And the answer is, well, we kind of don't need them in C# the same way, because C# is a managed language, higher level than C++. It manages memory, and the way it does instantiation and destruction a lot differently than C++ does. So one thing we can do, we see a lot of singletons being used, throughout our time. I know we had a texture manager, we had a sound manager, we had a collision manager. We had a bunch of different kinds of singletons in our STL implementation back in C++, and they all had the exact same pattern. So we had the exact same parts of the code. We had a static instance, creational method, we had a bunch of stuff. Well, why not template this stuff or create a generic class called Singleton that all other classes inherit from that are singletons? There's some really great reasons for this. One of them is, once I inherit from the Singleton generic, then we can test to see if a class is a singleton, right? Because we have an is-a relationship with the superclass, right? That's one thing. The other thing is we save a pile of code, because this stuff here that we keep on repeating over and over again, we don't have to repeat. And this is using not the classic singleton for templatizing, but actually the Magic Static singleton, which it works great. And so notice one thing we have to do when we templatize a singleton is we have to remove or delete explicitly the constructor function, the copy constructor, as well as, the copy constructor as well as the assignment operators. And we need to do this for both the singleton as well as for everything else. And that way, these things aren't regenerated here inside of our singleton template class, right? And so they're created inside of our child classes. All right, we need to do this. It causes issues. And so you can see that there are some syntax we're going to have to use to implement this class. So how do we implement a child class of the singleton superclass, the template class? Well, that can be a little bit tricky too. So when we do that, we have our manager singleton. Let's call it a manager or some kind of special class. This is just a name. We've marked it as final. So this is not something that's going to be inherited from this manager. It's just going to be a, kind of a final one. And then notice that we're using a public singleton, but we're also specifying the type as the manager singleton class itself, which is kind of weird when you see this kind of thing happen where the type is the child class. That's a weird syntax. And, when I first looked at this, I was like, wow, that's pretty ugly. But once you get through it and you do this, the cost of doing this is once, and then you're good to go. The other thing that's really weird, I see two weird things that we have. So one of them is this, like we talked about, this manager singleton that you have to pass in C++. And the other one is, well, this, right? Why do we need a friend for the friend class singleton of type manager singleton? Because this one doesn't exist right now. And what we're telling C++, whenever we use friend, the keyword friend is, hey, C++ compiler, I got this. I got this. Don't worry. This is what this is. I'm defining or declaring what this thing is without the definition, without the details. I'm going to define the details later, but trust me, I've got this, is what I'm saying to the compiler. And this can be somewhat dangerous because it doesn't yet exist. So we have to make sure we do the definition. So what do we do here? So then the first thing is, so first we inherit from the Singleton template superclass. That's what we're doing, passing in the class that we're inheriting, the child class information. And then we have one or more functions that we're going to access. We still make our private constructor or a default constructor private, as well as we override the private destructor, right? Set it to default or something else. You can define it if you like, right? So that's the first thing we do. And this is what's happening inside of the child class of the Singleton superclass. And then when we use it, the way we would use this thing is it would look like this. So here's some test code. So, hey, whatever the manager Singleton is called, we call the instance method, and then from there we call some function. When we do that, you're going to see that it returns some kind of results. This is what we would expect in any class that has some function. But I'm showing you that it works just fine, just like this. So exactly what we would expect, the exact same way we would expect this thing to operate is the way it would operate here, right? Based on our template. So kind of really cool. And so here, let's talk about some advantages. So advantages. An advantage of the Singleton is we get one single instance of an important class. And I'm saying important every single time because please don't use this all the time. It's only supposed to be for classes that you don't want to duplicate, that you can't. It might break something. Example, a renderer, a window, some kind of window resource, a database object, something that some kind of network instance. All those things should be pretty much singletons, but they should only be those, not for everything you want to make. You don't want to make singletons for every one of your enemies. That would be weird, right? So that a global access point, some way of accessing from anywhere in the code. That's another reason. That's the other advantage. And it's only initialized when it's requested for the first time. This is like lazy initialization. So really good advantages. There's a pile more disadvantages. One of them is it does violate the single responsibility principle, which makes singletons kind of the most loved and hated design pattern. Some people actually see it as an anti-pattern because it's not something that people would want you to use. They want you to instantiate new objects, but it does solve a problem, one or more problems, and it does solve two problems that we've talked about earlier. But again, if it's something that's going to help you and it makes sense, good. But it can also use to mask bad code. Like, for example, when the components of the program know too much about each other, we don't want this to be the case. We want to make sure that the singleton isn't overused. When we overuse a singleton, bad things happen. And the other thing is the default pattern requires some special treatment in a multi-threaded environment so that multiple threads won't create a singleton object several times, which is what we said. The classic singleton creation method does this. We want to use magic statics or other things in order for us to do this. And the other big one is outside of game development, we do a lot of unit testing. We do a lot of, and in some studios as well, there's unit testing. But we use test-driven development and behavioral-driven development outside of game development. And when it comes to unit testing a singleton can be quite tricky. So there's some disadvantages for you as well. All right, any questions around singletons and what they are, why we use them, and what the advantages and disadvantages are? Any questions? So I'm not seeing any questions right now, but let's go back to last week. Last week we kind of talked about Lab 4. And Lab 4 in a special video that I made, which was like, bonus content. I actually did create two singletons. One of them was for our BulletFactory, and the other one was for our BulletManager. And let's just revisit those again from last week. So again, if I look at scripts and I go to bullet scripts, we created something called a BulletFactory. Now in C#, we do not need a magic static, because what happens is C# takes care of it does a lot of things for us. It does marshalling, and it does a lot of our memory management for us. There's a lot of garbage collection and other things it does automatically for us. And what this does is it also makes it so that when we create a singleton like this, it works just fine. So here's something that, and it also supports, by the way, it can also support concurrency. It takes a little bit of work, but it can be done. So how is this working? One thing to note is when we made our BulletFactory from last week, we did not inherit from mono behavior. Mono behavior actually instantiates a public constructor outside of this class, and due to order of execution control that Unity uses, you can't guarantee that there's going to be only one instance of the BulletFactory constructor called when using mono behavior, because mono behavior actually inherits. There's actually stuff that's happening outside of your class, almost like what you're doing is creating partial classes. So there's a class here and there's a partial class somewhere else. Okay, and C# does represent and support partial class definitions and control. So that's something. The other thing is that, so the BulletFactory, so here's the BulletFactory. The first thing we want to do is we want to set up the bullet instance like we've done before in the past, where we say that the instance, because it's private static, instance is null. Notice how null is grayed out, if you will. And the reason for that in C# is you don't need to define that an object is null. It's automatically null unless you, as soon as we create something like this, we say private static instance, then it's assumed that this object starts off as null. It gets initialized, right? So if you look at the suggestion from ReSharper, it says a couple things. Should rename it so it's private. That's number one. And if I look at null itself, it says you don't need it. I can just remove this whole thing and you don't need it at all. Okay, the next thing is we have our constructor function which calls initialize. Initialize actually does some initialization, but here in the instance method itself, it does the classic check. It says, hey, does the instance exist? If it does, or if it doesn't, right, then make a new one with a new keyword. Allocate memory, give me a reference to the BulletFactory that we're making as an example, and return that instance back to the calling function or the client code. That's what it does. So this is your static instance, right? So again, it's separated a little differently. Here's your private static instance. Here's your public static get instance or creational method that uses the constructor function here. And this takes the place of the constructor function. Singleton. So we talked about this last week. And then in the initialize method, we also talked about how we want to load resources programmatically instead of dragging and dropping them. And so what we can do is inside the code, we have to have a resources folder. And inside the resources folder, we placed a prefabs folder where we are going to dynamically or programmatically load our enemy bullet and player bullet game objects here when we need them. All right, so we load them here in the initialize step. We have access to what they are. We now have a reference to those two prefabs. And then in the create bullet function, we actually use the mono behavior instantiate function and pass in a reference to one or the other object to instantiate an object of type temp bullet. Remember also what we're doing here is we're using mono behavior explicitly, and we're doing that because we're not inheriting from mono behavior. So in order for us to know what I'm talking about when I'm using instantiate, even though here I'm using Unity Engine, I want to be explicit and say that I want to use mono behavior instantiate. I'm calling the class itself and this static method that is going to be used to create an enemy game object, bullet, all right, which is going to be stored here in reference to temp bullet. So this is the only time we'll use a switch case. This is something we've saved when we used singletons here inside of our factory. So we still have a factory singleton that uses a switch case. And but we returned an instance of the temp bullet when we use create bullet. So this is the exact same thing we've done with the non singleton version of the factory. The only difference is here that the factory is not connected to any kind of empty game objects. So notice that there isn't a game object here called BulletFactory or BulletManager. And even the game controller doesn't have a reference to that script anymore at all. We've removed it because, again, and we can't add it even if we wanted to, because remember that we can only add scripts to an object in Unity that inherits from mono behavior. And since this doesn't, and for good reason, then we can't attach it that way. We need to use it kind of free-flowing, where we access the game object or the class directly from our script files, as opposed to it being attached to a game object in Unity in the hierarchy. So this is our BulletFactory. This is the first thing we made last week. And then we went and changed our BulletManager. So BulletManager, we use the BulletFactory. And again, BulletManager is also a singleton, right? We do the same pattern. So now you might be thinking to yourself, is there a way of using or creating a generic singleton instance where we can inherit from the singleton here in Unity, right? Similar to what we said when we wanted to templatize singletons in C++. And the answer is we won't do it today. We'll try and do it another day, where we can actually save some of this code. Because look, if I did that, then all of this code would be saved, and all of this code would be saved. And the only thing we'd have to put in here is only the specialization that we talked about from last day. So now BulletManager is also a singleton using the same structures we just talked about in BulletFactory. However, what we've done differently here, and due to us, to a suggestion from last day, was we created a list of Q game objects. And notice it's a kind of an embedded collection, a collection that's embedded in another collection. And what I did earlier was I kind of drew this out for some people that didn't get it. They were like, wait, I don't get how that works. And I kind of said something that looks like this. You have a list, and a list in C# is like a managed array. It's very close to a vector in C++. So the list is a generic type. You need to specify the type of objects. Remember, because in a list, which is a collection, every collection has to have similar objects that are stored within it. We have to specify what kind of objects are going to be stored in the list. In our case, there are a bunch of Qs, right? And because a queue is itself a collection, we have to specify what type of Qs does the list store. And we're specifying it needs to be a list of Qs of game objects. Okay, so that's what it looks like. And so this list, right, as an example, when we want to use it, the first thing we do is we create an empty object or empty container that pre-allocates or kind of saves kind of creates the shape of what we need for the list. So there's a little bit of memory allocated as soon as we create the container, but there's nothing stored in it initially. It's empty. And so in C#, we have to do this explicitly. We can't do it automatically like we do in some ways in C++. When I do this and I allocate a variable name in C++, it actually instantiates an object. Here in C#, it does not. We need to use the new keyword. So that's what I'm doing here. So we say that bullet pools is a list of Q game objects, right? That's what it is. And bullet pools, in order for us to start going with it, we need to allocate memory and create that empty container, which is what this would be right here. That's what this step does, makes an empty container. And then what we do is we loop through for the number of bullet types. And notice what we did last week, which was we kind of defined that we added a number of bullet types, which tells us how big it is, the enum. We can see that the enum has three members, enemy, player, and number of bullets. Enemy 0, players 1, and number of bullet types is our hack to kind of know instantly how many bullet types we have. And what we can do is we can convert that knowledge to an integer. We can do that. And then we can use that in a for loop to count, to iterate a couple of times, loop a couple of times, and we can add 2 queues to the bullet pools list. So when I add a queue, here is when I'm instantiating an object of type queue. And when I do this, the queue is empty. So I'm adding 2 new empty queues. So what I'm actually doing is I have a queue of type GameObject. And this queue of type GameObject, let's put it here. And let's suppose that the queue is just, we're going to make it a queue. And a queue, remember, has special properties where it's first in, first out, or first come, first served. Call it what you like. Think about it as a lineup. The queue right now is an empty queue. It's just an empty object like this. And what I'm doing is when I loop through, I kind of create an element, and that element kind of gets stored up in this list, and it's the element itself is a queue. And I can do that as many times as I'd like to loop through that. I loop through 2 times here because I have 2 types of bullets. Let's make another one. And the second queue, again, empty, gets added into the list, right? So again, as the second element in the list. So this is the second element. And we can access these things with their element index, which is 0 for the 0th element, like we normally have, because we're using 0-based counting here like normal, right? And 1 for the second queue, right? So those 0 and 1s. Remember that 0 pertains to, remember the enum, where we said that, and the enum is bullet types. And the bullet type enum, let's see if I can do this right, because last time I kind of used an escape character for this and it worked. Maybe it's not going to work this time. We'll see. But the bullet type enum, remember, had the enemy bullet as well as the player bullet, where the enemy bullet is equal to 0 and the player bullet is equal to 1. That's what really we're saying when we have that structure. Oh, it did retain it, right? So that's 0 and 1. If you think about it, what we're saying is that when we loop through, that 0 is the enemy and 1 is the player. All right, that's what we're saying. Okay. So this is the player queue then. Well, player. And these are player bullets. And these ones are enemy bullets. Okay, that's what we're talking about. So in order for me to access or add to the enemy bullet queue, right, I need to use the 0 index in the list. List, whatever the list is called, bullet pools, 0 in square brackets, where you're going to use the square bracket operator to access. We're getting access to this queue that's inside of the list. Can we do this differently? Absolutely. We could have used arrays. We could have used one big array instead of multidimensional. This is like a multidimensional array in some ways, but we have a multidimensional collection, if you will, right? Where the first dimension is really the collection itself, the list, and the second dimension is the different kinds of lists. So a list of queues. Very complex. All right, so then, and that's what we're doing here, and that's how you access it. So when we want to initialize, we not only do we create an empty container of the list container of type Q game object, but we're also adding to this bullet pools by making a new empty queue twice. We're making 2 elements. Then when we add bullets, we need to know which pool to add them to. And we can decide that by when the add bullet method is called, we have this type, and this type indicates, we're going to use it as an index, which of the pools that it's going to access. So if it's type 0, the enemy, then it's going to be bullet pool 0, which is the enemy pool, right? If it's type 1, which is the player, then it's going to access the player pool, which is 1, right? And it's going to use the onQueue method of whichever pool that I'm accessing. OnQueue is a special method that belongs to queues that allows me to add a bullet to the end of the list. And DQ, this is similar to pushback in C++. And DQ, we use the DQ method when we get a bullet. So get a bullet DQs or removes an item from the specified bullet pool, whatever that bullet pool is, and returns it out into the hierarchy. Okay, that's what it does. And one of the questions I got earlier today was, well, what about this count less than 1? What does it do? What does count pertain to? Count pertains to the queue, right? If I ever hover over count, it just tells you right there. It says, it gives me an integer related to the queue that I'm looking at. So if the queue is 0, it tells me how many items are in the queue. So when I add bullets, add bullet, I use the add bullet method to add bullets to either one of the queues. So for example, I might have the need to add a bullet to the enemy queue. So there's a bunch of enemy bullets. And let's suppose I add several bullets. And I also add other bullets. Let's make them different shapes so that we can see that they're different. We add the same or different bullets to the player bullet pool, right? And they're very different. And that's what we can do with these two structures. I can have different kinds of pools, right? A enemy bullet pool and a player bullet pool, and they can be both stored inside this list of game objects, Q game objects, what we like to call them bullet pools. Bullet pools. Okay. So that's the structure we decided to use last week just to optimize. We kind of said that this is better than using a bunch of switch cases. And that's why we decided to go that way. You could have done it again with other things, but that's what we use that, that structure so we can save space. And if you look up online and if you look to compare what we had before in lab 4A, so again, if I go to github.com, George Brown College, and you can see there's lab 4A and 4B. Let's look at 4A for a second, the previous version. And if I look inside of assets, and if I go to scripts, and let's take a look at that BulletManager, right? So BulletManager is right here. You can see in the BulletManager, we have a bunch of switch case. There's a switch case here for add bullet. There's a switch case here for get bullet. There's even a switch case for return bullet. All those three things have switch cases. And there's a lot of extra code here. Here we've optimized, so we don't need that. And remember that branching is a lot more involved and more computationally expensive than using accessing a collection through an index with the square bracket operator. Okay, so that's why we did it. That's our reason for doing what we did. Okay, but both of those two things now, BulletFactory and BulletManager, they're both singletons. Okay, this is just an implementation of what we talked about today for our the topic of today. Questions around the singleton design pattern, why you would use it, how you use it in C# and C++ or anything like that. Okay, let's stop this recording now. And what I want to do is I want to get into the exam details, midterm exam details, and I want to use the rest of our time together to discuss the exam and what I'm looking for, all right, from you guys. All right, so I'm going to stop recording. Right, so